So in this particular presentation, I'll be talking about 8086 instruction set. And this is the second classification, and this classification is based on strings. Subject is microprocessor KCS403. My name is Gaurav Parashar. I'm from the computer science department. As mentioned, in this particular presentation, we'll be talking about the string manipulation instructions, which is the category of the instruction set. Now, what are the string manipulation instructions? So what are strings basically? So strings basically are the sequence of bytes or words. Bytes means 8 bits and words means 16 bits. So these are the sequence of 8 bits or 16-bit words. So in 8086, instruction set actually includes the instruction for string movement, comparison, scan, load, and store. REP instruction basically is used to repeat the execution of the string instructions. The string instruction mostly ends with S or SB or SW, where S represents the string, SB represents byte, and SW represents the word. The offset or the effective address of the source operand is stored in SI, and that of the destination operand is stored in DI. And depending upon the DF, SI and DI registers are automatically updated. So if, say for example, DF is equal to 0, then SI and DI are incremented by 1 for 1 byte and for 2 for a word. If DF is equal to 1, SI and DI are incremented by 1 for byte and 2 for word. Now let's take the example of the mnemonics being used to do the string manipulation. So the first instruction is REP. So REP is actually used with flags. So if it is like REP said, so it repeats the comparisons, scans until DF is 0. Now let's talk about this. So while CX is not equal to 0, CX means the count. So while the count is not equal to 0 and ZF is equal to 1, repeat the execution of the instruction and CX is equal to CX minus 1. So the entire loop is represented by this particular REP set or REP. And REP NZ is actually the until the value of ZF, then is 0 flag is 1. In this 0 flag is 0 and this 0 flag is 1. Now coming to the move. So move, either you can move a byte or a word. So for moving a byte, we actually do some calculations. And how to move a byte? So if, say for example, the DF is equal to 0, then DI, that is destination index, is incremented by 1 and source index is incremented by 1. And if DF is equal to 1, then DI is decremented by 1 and source index is also decremented by 1. And the calculation goes like this, that data segment is multiplied by 16 and added with an offset. That creates a memory address. Okay. And if we are using a 16-bit extra segment register, so you'll use ES multiplied by 16 and add DI to it. So this gives you the MPE. So this is for byte and this is for word. Coming to the comparisons, so comparison either it would be a byte or a word. So comparison goes like this. So if like MA is greater than MAE, MA and MAE, then the carry flag is 0. 0 flag and sign flag all are reset. If MA is less than MAE, then CF is 1 and SF is 1. When they are both equal, then carry flag and 0 sign flag are reset and 0 flag is set. So this is how we do a comparison in the byte or word. So either the one string is greater the other string is smaller, or they are equal. Now scans. Scans basically scans the or compare a string byte or word with accumulator. So in this, it was comparing two bytes or string words. Over here, it compares with the accumulator, and the logic is same. AL, okay, it compares with AL. Now, what it does, so it loads this byte into AL or string word into AX. Okay, so load means you have to transfer the value. Store means it stores the byte from AL or a word into a string. So when you have something in AL and you want to transfer it to the memory location, so this is what you will use store for. And that's all in this presentation. Thank you.